Okay, everybody, welcome to chapter 9, which deals with hypothesis testing with one sample, testing using a single mean and a single proportion. So let's get into it. What is a hypothesis test? You can use a hypothesis test to, for example, decide if a dog breeder's claim that every Dalmatian has 35 spots is statistically sound. So it's kind of like a way to not exactly prove or disprove, but basically support or fail to support. Okay, so in this chapter, we're going to go through type 1 and type 2 errors. We're going to describe hypothesis testing in general. Then we're going to actually conduct and interpret hypothesis tests for a single population mean. Remember mu, when you know the standard deviation of the population. And then we're going to conduct and interpret hypothesis tests for a single population mean when you do not know the population standard deviation. And then lastly, we're going to conduct and interpret a hypothesis test for a single population proportion. Okay, so remember we were talking about statistical inferences. One way to do that is to make a decision about a parameter. Remember, parameter are characteristics of the population, yeah? So here's some examples of claims, okay? So one claim is a car dealer advertises that its new small truck gets 35 miles per gallon on average. Okay, another type of claim could be a tutoring service claims that its method of tutoring helps 90% of its students get an A or B. Another example would be a company says that women managers in their company earn an average of $60,000 per year. And of course, we've all seen the news where certain people claim that certain medications work amazingly well, right? So everybody has an opinion, right? And a lot of people can make claims about their product, but how do we really decide? How do we know if they're correct or not? Well, it's so great because there is a way to test someone's claim, okay? And a statistician will make a decision regarding these claims using a process that's called hypothesis testing. Okay, so what is a hypothesis test? A hypothesis test, it's basically collecting data from a sample and then evaluating that data. Okay, so then using the data and a specific test, we make a decision whether or not there is enough evidence to either reject or fail to reject the initial hypothesis, which we're going to get into then, which concerns the null and the alternative hypotheses. Okay, so to begin a test, we have to have these two hypotheses, and they contain opposing viewpoints. Okay, so it's really important that you understand the difference, and it's really important that you understand this little symbol here too, this little H sub O. It means, it's a shorthand way of saying the null hypothesis. So you think of the word null, it means like nothing, like zero, zip, nada, null, it's nothing. So you can think of the null hypothesis of something like there's no difference between the sample mean or the proportions, and there's no difference between a sample mean or a proportion and a population mean or a proportion. So it's also known as like the boring argument, the argument that is kind of obvious. It's kind of like the equality. Oftentimes it just either contains less than or equal to or just equal to. And this will make more sense as we go on. And the alternative hypothesis is usually what people want to claim. Usually it's what a person wants to prove or to show. Like, for example, they want to say, hey, my tutoring service, students get an A about 90% of the time, So their claim could be that the proportion of students that go to this tutoring service is greater than 90%, or equals 0.9, okay? And then the null would be something like it's less than 0.9, okay? So since they're contradictory hypotheses, we need to examine the evidence to see if we can reject it or not. And this comes in the form of sample data. Okay, so after we determine, like, so either the data is either going to support the null or the alternative, okay? If you're trying to show the alternative, then you want to reject the null hypothesis. And if we want to basically support the null, we fail to reject it. We think of it like that. It's kind of an interesting concept because you would think, well, why can't you just prove it directly? It's a lot harder to prove something directly than it is to disprove something, just to disprove something. It's a lot easier to disprove something than it is to actually prove something. Think about that for a second. I mean, how hard is it to prove an actual statement fully in every single case, all the time, absolute truth? It's really challenging, but to prove somebody wrong, so easy, right? It's super easy. You just need one example and you're done. Okay, so anyway, that's just like general logic. Okay, so once we determine like what hypothesis the sample supports, the null or the alternative, we make a decision. Okay, so there's two options, right? So the first option is we reject the null hypothesis, or we reject HO if the information supports the alternative hypothesis. And we do not reject, the other decision is we fail to reject, do not reject, in other words, decline to reject. These all mean the same thing. If the sample information is insufficient to reject the null hypothesis. So basically, the way that this kind of works, we're trying to disprove the opposing argument so that it looks like our alternative hypothesis is more favorable. That's usually how this works, okay? Kind of think of it like, all right, so going back to this tutoring thing, right? Like the tutoring example. Like if my alternative hypothesis is that the proportion of students who go to, let's say it was my tutoring center, get 90% or above, their average grades are 90% or above, then my P would be greater than 0.9, and then that would be my HA. My null would be that it's less than 0.9, less than or equal to, less than or equal to 0.9, so you can do that, or you can also say, there's just like a different ways that you can phrase a situation. So if I disprove the null, then it supports my claim that it's greater than 0.9. All right, so here's some more symbols. So if your null hypothesis has an equal sign, okay, then the alternative hypothesis will have a does not equal sign, this little equals with a little dash through it or something. Or it could be a greater than or strictly less than. Notice that there's no equality here, okay? So notice one thing too. The alternative hypothesis never has an equality, yeah? Look at it. It's only either does not equal to, less than, or greater than. That's the only options for alternative. Sorry. For the null hypothesis, remember the boring hypothesis, right? The whatever. So something we want to reject it. The choices are either they're equal, greater than or equal to, or less than or equal to. Okay, so super fun example. Let's look at this. So here, sorry, I went too far. Oh no. Well, now you know the answer. So here's an example of a null and alternative hypothesis. No more than 30% of the registered voters in Santa Clara County voted in the primary election. So if I say this, I'm like, okay, this is a percentage. That means I'm going to use this little p for proportion or percentage, right? It says no more than. If the null statement is no more than, then that definitely means less than or equal to 30, okay? So this would be 0.30. This actually should have a little point right there. I don't know why it doesn't. Okay, and then if, so just fix that in your notes, it's 0.30. So then here, the alternative hypothesis, if the alternative hypothesis is more than 30% of the registered voters in Santa Clara County voted in the election, then you would write my HA is P greater than. Why? Because of this keyword more than, okay? That implies strictly greater than, and then it would be 0.30, right? So this is a typo. All right, so I'm sorry. Let's just pretend you can't see this right here. But if we want to test whether the mean GPA of students in American colleges is different from 2.0 out of 4.0, then the null and the alternative hypothesis, so this is another keyword, different. Notice that it didn't say more than, greater than, less than, nothing. It just says different. When you see this word different, it really just means does not equal to, right? If you're different than something, you're not the same. Yeah, it's simple as that. Okay, so this is like our claim. We're trying to test this, whether this is true or not. So we put that here, our alternative hypothesis, because if we reject the null, since these two arguments are contradictory, if we reject this hypothesis, then the alternative hypothesis is looking pretty good. It's like we're supporting it now, you know? So the null would be, oh yes, they are, the mean GPA of students in American college is 2.0, and the alternative will be that the mean, mu, does not equal 2.0. So you're always, it's going to be structured like this, where you have HO, colon, and then you're going to have a mu for mean, or you're going to have a little p for proportion, okay? That's usually the way it goes for now. All right, so let's try this again. We want to test if college students take less than 5 years to graduate from college on the average. Okay, so let's think for a minute. You can push pause if you want to and see if you can write two statements, a null and alternative hypothesis. You can try it using words, or even better, try to do it using symbols, okay? And then we'll compare answers. Okay, so let's say he had paused it and tried this. So you tried this, and let's see what we get. Okay, so then the alternative, it says we want to test if college students take less than 5 years. So that already kind of tells me, oh, okay, we want to see if this is true or not. We're trying to test this claim that mu, the average, so keyword is average. So when you see the word average, that kind of tells you, oh, okay, I need to put this little weird m for mu, meaning mean. We want to test that if the average, on the average, if college students take less than 5 years, so then that's less than. So less than is, here, the symbol. And then, so since we know what the alternative, the null has to be contradictory to this, okay? So it's just that, okay, then the null hypothesis would be like, no, yeah, college students take 5 years or more to graduate from college on the average. Okay, let's try another one. Okay, so in an issue of U.S. News and World Report, an article on school standards stated that about half the students in France, Germany, and Israel take AP exams and a third pass. The same article states that 6.6% of U.S. Students take advanced placement exams and only 4.4% pass. So we want to test if the percentage of students who take AP exams is more than 6.6%. Okay, so what do you guys think this is going to be? Just write anything down, right? HO colon, HA colon, and then we know we're talking about what? Percentages. So which one are you going to use, mu or p? Yeah, if you said p, good job, because that's exactly right. And now read carefully to see what symbol you're going to use. What inequality symbol are you going to use? What type of what's going to be your null? What's going to be your alternative hypothesis? Okay, so we were testing if the percentage of students who take advanced placement exams is more than 6.6%. That's our alternative hypothesis. We have, so HA is P is represented by the symbol P greater than, strictly greater than, because that's the word more than, 0.066, which is 6.6% expressed as a decimal. So this is our alternative hypothesis. So therefore, our null hypothesis has to be P less than or equal to, right? These are contradictory, 0.066. Notice that these are the same number. This is the same letter. These are the same except for one is the O signifying the null and this little A signifies alternative, okay? And I'm also going to post a little quiz I wrote, quizzes. on our Canvas under announcements. So be on the lookout for that. Okay, great. So that's it for 9.1. Your homework is to remember practice section 9.1, 1 through 10 all. Good luck, and I will see you on the next video.